Hi everyone, this is Sunny from Database Tech. So today I had come up with one more new session on SQL Server Database. In today's session I will explain what is clustered and non-clustered index. But before we start we need to understand why do we need indexing. So let's first understand that. As you can see in this figure we have multiple pages 1, 2, 3 and 4. Now suppose these pages contain account details. And if I ask you, okay, get me the account details of Jeffrey and Sandra, what will you do? You have to look down all the pages to get the account details of Jeffrey and Sandra. And it will take longer time, which is obvious. Why? First, the data is not sorted, which means the data is not alphabetically arranged. So because of that, you don't know where can the account details be. It can be in the start, it can be in the middle of page, or it can be in the end. So with that, you have to check all the pages from to get the details. Now same thing happens in database as well. Let me show you one example from SQL Server so that you can understand this in a better way. This is SQL Server and we have one table named customer 1. Now consider this table as customer details table. Now from this table, if we need customer details where ID is equal to 3, how we can fetch this data? We will simply write down the select statement, select start from customer 1 where ID is equal to 3. This query will give us this data. But what happens internally? Internally, compiler has to check all the rows from this table to get this data because it doesn't know where can this ID be. It can be in the start, it can be in the middle, or it can be in the end. It can be anywhere in this ID column. So it will take time. Might be in this scenario we will get our data quickly as you can see. But there can be the scenario where we have huge number of records, huge number of rows, around millions of rows. At that time when compiler has to check all the rows, it will take time. If we need just small data, the compiler still has to check all the rows from the table. If data is not arranged, you can see there is no order, no sorting for this ID column. No index has been applied. So that's why compiler has to check all the rows. Now with this approach we had disadvantages. What are those? We had performance issues. We will not get our data quickly, which is obvious. Now to sort out this issue, we have indexes. So now you have understood like why indexing is required to get our data faster so that we can get our data quickly. You have seen in this example also the data was not sorted. Same we checked in this table out as well. Now we will understand here like what type of indexes we have. In SQL Server we have two types of indexing, clustered index and non-clustered index. So let's first understand what is clustered index. In clustered index I had given some points here. We will do them one by one practically in SQL Server. So let's go one by one. Now from the first point it's saying defining a column as primary key makes that column the clustered index of that table. Now what does that mean? Let's understand this practically in SQL Server. So this is one more session that's opened. First we will draw up the table if they are already created. So now we will do them from the scratch, which will help you to understand everything. So let's create one table named customer 1. So table created, command completed successfully. We have created table named customer 1 in which we have columns ID, name and salary. So what's next? We will insert some data. So we have inserted data using insert statements. Now we will check the data using select statement from this customer 1 table. As you can see now, we have below output from this table. And if you will notice one thing here, the data has been inserted in the same order the way we have inserted here. 1, 5, 2, 3, 4. 1, 5, 2, 3, 4. There is no sorting, no data is not arranged here. It gets inserted in the same order. Why? Because the indexing was not applied on this ID column. Now you will be thinking how we will get to know whether index has been applied or not for this table. For that, there is one command, that is sp help index table name. What's table name? It is customer 1. Execute this query and you will get to know whether index is applied or not. In the message you can see object customer 1, which is table name, does not have any indexes, which means index is not applied on this table. Now what we will do now, we will create one more table. So let's create this table with same columns, same number of columns, but there is one small change. We will define this ID as primary key. As we checked in definition that once we define the column as primary key, clustered index gets invoked for that column. Let's see it's working as expected or not. So what we have done, we have defined this ID as primary key. Now let's create this. Okay, so how we can check now whether index is applied or not? For that, as I said, sp help index table name. What's table name? It is customer 2. Execute this again and you will get to know. So you can see in index description that clustered index has been invoked for this table. So which is true. Like if we define this column as primary key, that clustered index gets invoked for that column. So which is true. Now what's next? We will insert some data. So we are inserting data in the same order the way we inserted for customer 1 table. 1, 5, 2, 3, 4. But you will check the difference here. Now let's check the data from customer 2 table. Just check the difference here. What is the difference? Now for the ID column, the data has been sorted. It's arranged 1, 2, 3, 4, 5. Although we inserted data in this order for this table 1, 5, 2, 3, 4, but data gets rearranged by own. What it means? It means if you are creating clustered index for that column, data gets rearranged. Now the clustered index determines how data is going to store in the table, which was not happening in the customer 1 table where index was not applied. But here when we apply index, data gets sorted by own. And now for this table, if you need the details where, if you need the customer details where ID is equal to 3, now the compiler knows, okay, after 2 it's 3. So when it fetches the 3, it doesn't need to go to 4 and 5 or the remaining rows. It will get the data and we will get our data quickly. But for the table where cluster index was not applied, it has to go to all the rows. But here it doesn't require. If we need data like we need 2, then it knows, okay, after 1 it's 2 because data is sorted now. So it doesn't need to go to 3, 4 and 5. It will skip that. It doesn't needs. So that is the benefit of indexing. And how we have created the index? By defining primary key for this column. That was point number 1. Now moving to next point, we can create only one clustered index on a table. To make any other column the clustered index, first we have to remove the existing one. Now let's understand what it exactly means. So let's create one more clustered index for this table. So we have the table customer 2. We will create one more clustered index for name column, because now we need to create index for name column. How we can do that? By using query. By using query also we can create clustered index. So how? Let's see. Create clustered index. So this is the index name. You can give any meaningful name, but I had kept it as clustered index so that you can understand it is clustered index. On table name, was table name? Customer 2. In the brackets you give the column name for which you want to invoke index. So we will give name and the order will be ascending. So the query is done. We have created clustered index for name column. Let's execute this query. It's saying cannot create more than one clustered index on the table customer 2, which we have seen in the definition. We can create only one clustered index, which proves our point that we cannot have more than one clustered index for a table. Then how we can create clustered index for another column? For that, we have to first remove the existing clustered index. Now how we can remove that? We can do it from Object Explorer also. So there from the left side you can see Object Explorer. Go to the table name for which you have invoked the index, and then you will see the indexes. Expand that. Now your index is there. Right click and delete. Okay. So the index which you have created by defining that this column as primary key, that we have removed from Object Explorer. Okay. Now what's next? We will execute this query and create index on name column instead of ID column. Command completed successfully. We will check the data again from this table. Here you can see now we have created clustered index on name column, and data is now arranged for this column. You can see it's coming Bhupesh and then Mahesh and R, S and S. Because we had given the order as ascending, it will be like that. If you want to make it first, Suresh should come, and then you have to change the order here and make it descending. That's how we can create clustered index using query. So we have understood like we can create only one clustered index, and if you want to create one more index, first you have to remove the existing one and then you can create the new one using query. Now moving to third point, we can create an index containing more than one column is called composite index. Possible to have more than one column for that index created. Now what does this mean? Let's understand this. So here we have seen we can create clustered index for single column. But we need to understand first why it is so. See, here the table we have table customer 3, and if we have created index for name column, so we can sort the table for single column. Now if we create one more index for ID column, will we get this correct output? No, there will be the data mismatch. We cannot sort data, we cannot sort the table for multiple columns. Either we can sort for ID column, either we can sort on basis of name column or for salary column. But we can sort data for single column only because we have only one table. This is the base table, and in base table we can sort for one single column only. So that's why we cannot have multiple clustered index for the table, because indexes are getting created in the same base table. It's not getting stored at different location. It's getting created on the same base table. So this is base table that we have. We are creating index here. So it's getting created here only. And data is getting rearranged. When we create index, data is getting rearranged. It's changing, and it's changing as per the ID column. And if we create one more clustered index for name, then there will be data mismatch, and it's not possible to have clustered index for multiple columns. So it's not possible. Now, if in case there's a requirement like we have to create clustered indexing for multiple columns, and that for different scenario, how we can achieve that? For that we have composite index. So what's composite index? Composite index is adding one more column. Now suppose if we need to create index for name and salary, how we can do that? We can add here salary descending. Okay, instead of creating one more clustered index, see, if we have, when we used to create one more clustered index here, one, and if we make this salary and we'll try to create clustered index, it will not work. But if we add this column salary here in the same index that we have already, this will work, and this is called composite index, and it works in different scenario that I will show you just a bit. So let's execute this first. The operation failed because index was straight with the column. Okay, this will not work because there is already one index that has been created for name column. So first we have to remove that. How we can remove that? Either we can use Object Explorer, and I will also show you how we can drop the index from query. For that you can use drop index customer to table name, and then you have to provide index name, which is clustered index. Execute this and our index will get dropped, removed. Now we can execute this. So command completed successfully. Our composite index has been created. Now here we have added two columns. Now the data will get sorted for multiple columns. Now you will be thinking, as I said earlier, we cannot sort data for multiple columns. Then how is this possible to sort data here? So this works as per this works for different approach. For this we have different approach. What is that? Composite index works from left to right. How? Let me show you how. See, it works at that scenario. In that scenario, if we have same names, now suppose first it will sort on basis of name column, name, which is the order is ascending. First it will sort on basis of that. But now assume we have two names, two same names, Suresh, and the one we had one more row. For that also we have Suresh. At that time, what will happen? Which row will come first? At that time, the salary will get involved, which we had given in the composite index. Now, if you have a requirement like if we have two names, same two names, then it should check for the another column, which we will give here. So at that time it will check for another column. It will check, okay, this is salary and it is descending, so the max salary will come first. So in that cases, what will happen, if we have two similar names, it will check, go to the salary column, and it will check, okay, which salary is max, so that will come first. Let me show you how. For to understand this, what we will do, we will insert one more row in this table. Insert into customer to What will be that? First we will give ID and then Suresh, which is same name, it's already there, Suresh, and then we will give salary as 9,000. Okay, Suresh is already there. So we are inserting the same name again. Now let's execute this query and check the data from customer 2. Here you can see for these two rows, Suresh is same. Now which row will come first? It will go to salary column. It will check here, okay, it is descending. So the max salary will come first, which you have seen here. So max salary is coming first for the Suresh row. If we change the order here, let's change it and make it descending. Make it ascending. At that time, this 3000 will come first. So let's change it. Ascending, execute this. Okay, it will not. First, we have to remove this. As I said, we can have only one clustered index. Now execute this again. If we check the data again from customer 2, 3000 will come first where we have same names. Okay, so in these scenarios, composite index works. And if you get a requirement like this, you can use the composite index for that. So that was clustered index. Now we will understand what is non-clustered index. Non-clustered index stores the data at one location and indexes at another location. Now what does that mean? Let's understand this. So we have this non-clustered index. This is base table, and base table we were having same base table for clustered index also. In clustered index we have seen indexes was getting created in the same base table. But in non-clustered index, so here we created index for ID column in the same base table. But in non-clustered index, indexes are getting stored at different location. So there is no dependency. Base table is stored at different place and indexes are stored at different places. Okay, so this is the point, like index stores at different at non-clustered index stores the data at one location, which we see in the base table, and indexes at another location. Indexes contain pointers to the location of the data. Now you have seen here, so this is the index that we created for name column in non-clustered index. So each record have the row address, as you can see, and these are called pointers. So these are pointers of these records. So here if we have index and each record will have the row address, which are called pointers. Non-clustered index requires additional disk space because non-clustered index are stored separately, which is true. See, here the non-indexes are stored at different location, so it needs extra space. It needs extra disk space, which was not happening in clustered index. So because indexes were getting created in the same base table, it doesn't need any space. But here they are getting created at different locations, so it needs extra space. Non-clustered index is slower because it has to refer back to base table. Now let's understand this. Here, at time of clustered index, if we need data where ID is equal to 3, it will check the same data in the same base table. There is no extra lookup because indexes are created in the same base table. It's getting sorted. But here in non-clustered index, we had indexes placed at different location. Now if we need data, if we need data where name is Suresh, so Suresh has some pointer, some row address. It will first check this row address and then it will find the row address from this base table, and it will match that row address and then it will give us the data. So here in non-clustered index there is one extra lookup, which makes this non-clustered index slower than clustered index. A single table can have many non-clustered indexes, as an index in the non-clustered index is stored in different places. Let's understand this as well. So here in clustered index you have seen we can create only one clustered index because there is dependency and indexes are getting created in the same base table. But here in non-clustered index you have seen there is no dependency. Base table is placed at different place and indexes are getting created at different location. So we can create multiple indexes. We can create index for gender, for city, for salary, for name, for ID. So we can create indexes for each column in non-clustered index. Because there is no dependency, it will not impact the base table. Okay, so that's why it's possible to have multiple indexes for non-clustered index. Let's understand this in SQL Server practically. What we will do, we will create one non-clustered index. And how to create the non-clustered index? Create non-clustered index. This is the name. You can give any meaningful name on customer to table for will create for ID. So let's create this. Let's execute this query and see. Command completed successfully and we have created non-clustered index for ID column. Now what we will do, we will create one more clustered index and here we will give it name as 2. Now we'll create for name column. So let's execute this query as well. It's getting created, so we have now two clustered non-clustered indexes for this table. Let's create one more and make it 3. Now we will create for salary column. So by this we have understood like we can create as many as non-clustered indexes for a table. Okay, but it was not possible in clustered index. And before we end, I will suggest like see, we should create indexes for that columns which we are going to use in where clause, which we are going to use mostly in where clause. Now let me give you one example of ID. So we mostly use ID like select star from data from table name where ID is equal to 5, where ID is equal to 3, or where name. If that column is getting mostly used, it's better to create index for that column only. Okay, otherwise don't create indexes. So one more thing like see textbook also you can take an example of non-clustered index. Like you may have seen in the textbook we have context, we have figures, we have tables, we have maps. So we can create as many as indexes here in non-clustered index which you can see in the textbook also, because textbook also have multiple indexes. Like we have tables and for that tables we have pointers like 67 which is a pointer. So you can check okay tables are placed at 67 page number, you can go to that page number and have an idea of the tables. Similarly figures, we have figures and figures at 45 which are pointers. So they work same like non-clustered index. But in dictionary you have seen data is sorted. If you find apple it is at the same place. You will not find apple in another place. So because the data is sorted in dictionary, same we have sorted data for clustered index. We sort data for ID column. So that's why we have only one clustered index in here. Okay. So dictionary works same like clustered index and textbook works same like non-clustered index. So that was it for today's session. I hope you have understood. In case not, you can provide your comments so that I can reply back. And if you liked today's session, you can subscribe my channel so that I can post more sessions on same. With this, let us wrap up the session for today. We'll come up with the next session shortly. Till then, have a nice day. Bye bye. Take care, be healthy, and be safe.